So the purpose of this video is to illustrate how glucose or sugar is converted into energy. Specifically, what vitamins and minerals are needed to convert glucose into energy. So the main energy currency for us in our bodies is something called ATP. ATP is used to pretty much help us do everything that our body needs to do, from thinking, breathing, moving, heart beating, regeneration. Every aspect of our body requires ATP. Now ATP is in a way generated from glucose by turning glucose into electricity in a way. So again, the point here is to illustrate what vitamins and minerals are needed and where they're used in the process to convert glucose into energy. So it may seem a little overwhelming, but just remember that that is the objective here, is just to highlight the vitamins and minerals that are needed. With that being said, let's get on with it. So the overall process is called cell respiration, which is basically making energy, or ATP. So we're going to start with glucose inside the cell. So glucose is a six-carbon molecule, and the first step to converting ATP, glucose into energy is going through what's called the glycolysis cycle. Now this happens inside the cell, and glycolysis basically means sugar splitting. Now that's exactly what's going to happen. So glucose is going to be broken into 2 3-carbon molecules here, but we're actually going to lose energy doing that. We're going to lose 2 ATP doing that. But from there, we're going to convert those 2 3-member carbons molecules into something called pyruvate. Now doing that, we actually get 4 ATP from that, which is our energy. So we're up 2 ATP overall in the beginning process of cell respiration. Now I wanted to highlight here that the vitamins and minerals are denoted in green. The electrons we're going to use as a currency, as an electrical process toward the end, is in blue, but we're also going to use protons as part of the energy required to make ATP, and they are going to be in red. So right here we already need a niacin vitamin. In the beginning process we need 2 niacin vitamins, and they are going to carry 2 electrons for us later on in the process. And these 2 hydrogen protons are also going to be used later in the process. So once again, from glucose to 2 molecules of pyruvate, we gain 2 units of energy in ATP. Now pyruvate is going to be converted to pyruvic acid. And this happens in an organelle in the cell called the mitochondria. So it's kind of a little inclusion in the cell, and then it's called a mitochondria. So pyruvate, there'll be 2 of them, are converted into pyruvic acid. And we'll have 2 molecules of this. And I know it looks very complicated and everything, and it is, but just bear with me, we're illustrating where vitamins and minerals are used. So with 2 pyruvic acid, or pyruvic acid to be converted into our next necessary molecule, acetyl-CoA, we need 11 atoms of sulfur. We need a riboflavin molecule vitamin, another niacin, and a thiamine. And these are all listed in the far corner over here. And these vitamins are all part of proteins. They are all part of a larger protein complex. So once again, we need 11 sulfurs, atoms, niacin, riboflavin, and Thiamin B-1 to convert pyruvic acid into acetyl-CoA. Now as you can see here, I have coenzyme A as highlighted in green, because coenzyme A is actually made up of B5, or pantothenic acid. Now this molecule enters something called the Krebs cycle. Now the Krebs cycle is called the Krebs cycle because the first molecule in the cycle is made from the last molecule in the cycle with the chemical from pyruvic acid. So it's a cyclical process. The end product helps make the beginning product again. And it's called the Krebs cycle. And in this process, we need another niacin, and we generate these electrons here in this process and hydrogen. And we also generate a hydrogen in the previous process with a hydrogen ion. So we also need a riboflavin, and we generate 2 ATP, which is what we're looking for. And overall we generate 6 protons. Now these protons are made the same time this product is made, nicotinamide adenine dinucleotide. This is the reduced form, so this has electrons to share, and these are the protons. So this happens in the mitochondria. Now these protons, everywhere you see them, they get pushed over here, and they get pushed across this membrane, and they collect over here, and they create a potential, like an energy potential, because more of the same charge, they create an energy in that regard. So all these protons here are getting pushed across something called the electron transport chain, which is also in the mitochondria. And what that is a fat. It's like a fatty layer, and in that fatty layer we have proteins. These 1, 2, 3, 4 proteins, and this is a coenzyme, CoQ10, and this is a cytochrome. But we have these major proteins in this fat layer because these are all charged molecules. So, you know, like water soluble doesn't mix with fat soluble. So all these proteins here have to carry these water soluble aspects across the fat layer, and so that these protons can accumulate and create a kind of energy gradient. Okay, so all the protons in red, like I said, are being ferried across these carrier proteins up here, and all these electrons that you see in blue are entering these same areas, but they're traveling down the middle of the fat-soluble membrane area by iron and sulfur and flavin, or from riboflavin, and copper. So these are all helping the electrons move through these proteins, and then it comes out on this side, back on this side of the mitochondria, and it helps create water. And this is possibly done to help stabilize this charge, this high positive charge, to have these electrons be carried through this fatty membrane. So in this first complex, this is complex 1, this is a multi-protein complex, we need a lot of iron and a lot of sulfur, and we also need, like I said, a riboflavin. In this small area right here, this is a CoQ10 complex. So you hear that you take CoQ10 for your heart. There is a lot of mitochondria in your heart because it needs a lot of ATP. So you take CoQ10 to improve your heart function. This is one of the places it's found, in the mitochondria, right here in the electron transport chain. Then we have another complex, complex 3, which requires a lot of iron and a lot of sulfur. And complex 4 also needs iron and copper to perform its job correctly. And honestly, I was very surprised when I did the research for this video how much sulfur and iron we need to carry this process to convert sugar into our energy. And over here I have sulfur. I found 33 atoms of sulfur are needed in what I've researched here, and 27 atoms of iron are needed, and it's something that I wasn't really prepared for. So anyways, carrying on, so we have these carrier proteins in the fatty layer coming out at complex 4, turning a half of oxygen and 2 protons into water. So it's stabilizing the charge. And we have all this energy built up over here of these hydrogen protons, and they're going to be pushed through something called ATP synthase. Now ATP synthase, with the power of the hydrogen protons, is going to turn a basically spent battery called ADP into a charged battery called ATP. Now this energy electron transport chain has the capacity to generate 34 ATP per glucose. So that's pretty amazing. Now, one way that we are not allowed, we won't be able to use the electron transport chain is because if there's no oxygen here. So this has to be in an oxygen environment. It has to be anaerobic for us to get 34 ATP. So that's pretty much a really kind of intense look at how we use these vitamins to make sugar, to make energy from glucose. And once again, I just want to kind of go through what vitamins and minerals that I had discovered were needed and in what way. So we have 10 niacin vitamin molecules, and we have 1 thiamine. I found pantothenic acid, riboflavin. We needed 5 molecules in what I've illustrated here. 33 sulfur atoms, 27 iron atoms, and 2 copper atoms, and even biotin. I found biotin in this large process here, an ATP synthase. It's actually needed an ATP synthase. So I just wanted to highlight that because in my previous videos I say that it's needed to convert carbohydrates to energy or fatty acids to energy. And fatty acids and protein also enter this process in different places than where glucose does. So this is involved in converting all major macromolecules into energy, which is our ATP. So that being said, I just want to re-highlight that brewer's yeast has got a lot of the B vitamins, and it's got a lot of the minerals that are going to help with this. It's got the copper and a lot of the B vitamins that I've mentioned here. And because of this, I actually had done some research into sulfur, and I had discovered that it's the 3rd most abundant mineral in our bodies, and it's probably we are probably one of the most deficient in sulfur. So that being said, I'm going to leave an article below that you can kind of just get a broader understanding of the role that sulfur has throughout our body. And I'm also going to leave a link to a sulfur supplement that I'm going to start taking in hopes of improving my energy output from glucose. So anyways, once again, this is very busy, and I understand that, but once again, the highlight here is just to let the viewer, to let people know that it's not just sugar that we need. We need a lot of other things to make sugar work for us. So, thank you. Thanks for watching. I hope that you guys have gotten something out of this. Thank you.